If the product D equals ABC of three square matrices is invertible, then A must be invertible, so are B and C. We need to find a formula for A inversed that involves only A, B inversed, C inverse D, and or D inversed. Well, let's see what we can do here. Since A, B, C, and D are invertible, so matrices A inversed, B inversed, C inversed, and D inversed exist. So we can write down that A inversed, B inversed, C inversed, D inversed exist. So we are given that D equals A, B, C. We can multiply this equation by D inversed on both sides. So we get D times D inversed equals ABC times D inversed. Well, we know that D times D inversed equals identity matrix. So identity matrix equals ABC times D inversed. Well, now we can pre-multiply this equation with A inversed on both sides. So we will get A inversed times identity matrix equals A inversed times A, B, C, D inversed. Here we have A inverse times A, which equals identity matrix. So we can rewrite it as A inversed. Obviously, A inverse times identity matrix is just A inversed. So A inversed equals identity matrix times B, C, D inversed. Again, multiplying by the identity matrix is same as multiplying by 1. So A inversed equals B, C, D inversed. So we have found the formula for A inversed, and it states that the inverse of matrix A equals B times C times the inverse of matrix D.